If you did enjoy this video, please like, subscribe, and recommend channel if you like. If you want to support the channel a bit more, buy those t-shirts I created, or support channel on Patreon. Click on my quote question I post from time to time or whatsoever. Definitely not sponsored by Arizona and Hagoromo Chalk. Good morning, fellow mathematicians. Welcome back to another exercise, okay? Like I said in the previous video, we have dealt with those two cases right here. We have dealt with this thing right here. And this time we would like to see if... What's this loud noise? Never mind. We would... That's so distracting, mate. Fuck off. We would like to see if we can find an integrating factor of the form h of x over y, or y over x. But it's going to be x over y, okay? This is something that sometimes works, and I found one where it actually does work, okay? So... Let us go ahead and get started. As always, we would like to check it first if this thing is exact or not. And you can see at a glance that it is not exact. So if we differentiate this thing with respect to y, it's going to be free. If we differentiate q, so negative x, with respect to x, it's going to give us negative 1. Ain't exact, mate. 3 is not equal to negative 1. Not in the real numbers, okay? It's not something that works. So we have to find an integrating factor. And as always, looks like this right here, and this time h of x over y, where our m of u, where u is nothing but x over y, is going to be this abysmal individual right here. It is absolutely not beautiful individual. But we're going to go through the length of actually solving this little differential right here and see what we get. So m of u is now nothing but, you just love when I say this. We're going to get y squared times del yp is going to give us 3. Del xq is nothing but negative 1 in this case, because we have to subtract it. So plus 1. It's going to give us 4, okay? 3 plus 1 is 4. Public service announcement. 3 plus 1 is 4, mate. Over x times p is 3 times xy plus y times x, so negative x times y. Overall, we are going to have 4 over 2 times xy. I hope you can see where this comes from, okay? Because this thing right here is nothing but x times y. 3 minus 1. 3 minus 1 is 2. Public service announcement. 3 minus 1 is 2. Mate, if you introduce the negative integers, or just the inverse of the addition. Never mind. We are not doing algebra right here. We are doing straight through analysis, mate. This is going to result in a 2 right here. So 4 over 2 is nothing but 2. No, not a public service announcement right here. So 2. And then we are going to have y squared over x times y. And as you might see, this, and that is going to cancel out, leaving us with y over x. Y over x is 1 over u right here, because u is x over y. If we invert those under the condition that x and y are not equal to 0, we don't want that. It's going to be 2 over u. Meaning, this right here is really nice. That's once again a really small and compact thing we have to integrate over. Our h of x over y is the exponential function of, okay, we are going to get 2 times the integral of du over u times e snug. Okay, so once again, natural log of u is nothing but x over y, so exponential function of bringing the 2 into the natural log, so natural log of x over y squared, in this case, going to put it like this, looks quite ugly, e snug. Now, exponential function of natural log, this is why I constructed those examples right here, because it's always going to turn out quite nicely in the end, is going to be x over y squared e snug. And this is our integrating factor. It looks nice and dirty, and we can just simply check, as always, if this integrating factor actually makes our inexact differential equation an exact thing. Meaning del y h times p is this, nothing but del y, don't forget that, 3 times y, and then x over y, but the whole thing squared. So x squared over y squared. This and that is going to cancel out, leaving us with 3 times del y, x squared over y. 1 over y is nothing but y to negative 1th power, so we can bring the negative to the front, and then we are going to be left with negative 3 times, this is x over y squared. I hope you can see where all of this came from. Now, what is del xq? H times q. This is going to result in, don't forget, negative sign right here. This is important because we also had a negative right here. Okay, with a positive sign it wouldn't work this nicely. Wouldn't work out this nicely. Probably. I don't know. Who cares? No one cares. Seriously. So we are going to get negative x. I forgot the differential once again, so negative x. And then x squared over y squared. 1 over y squared is a constant. We can bring it to the front, leaving us with negative y squared del x, x to the 3rd power. If we differentiate that, bring the, that's a negative 2th power, bring the 3 to the front, reduce the power by 1, leaving us with negative 3 x over y squared. And voila, exact differential equation after actually calculating our integrating factor. I did 3 in a row because I'm too lazy to write all of this out once again. Those were the 3 exercises, and there's going to be one last exercise, namely solving a partial differential equation to actually get the most exact of our, the most general integrating factor ever for one exact differential equation. It did work out nicely there, so that's why I'm going to make a video on that, because people requested me doing partial differential equations a little bit. I'm not a master in that field of mathematics, but I can give it a shot. If you did enjoy this video, please like, subscribe, and recommend channel if you like. If you want to support the channel a bit more, buy those t-shirts I created, or support the channel on Patreon. Click on my quora question I post from time to time, or whatsoever. Definitely not sponsored by Arizona and Hagoromo Chalk. I'm wishing you guys a flammable day. Up until the next video, ciao. This was absolutely a mixed up outro. Love you guys, appreciate it. Ciao. This is how I say it. Hanna. Selbst mit den schlechtesten Regeln kommt bei meinem Staubsauger auf keinen Fall mehr als 1%